Hello everyone, this is Karmeet. In today's video, I'm going to talk about my kinematics-calculator project in GitHub. Firstly, I'm going to show you how to get here. So you go into github.com. My user is puppet2785 and this is the repository kinematics-calculator. So over here, this is my readme. Honestly, I just made this readme using ChatGPT. I didn't really understand Markdown syntax, so I wouldn't have been able to write all this by myself. Now, it actually implements the big five equations, which I'm gonna explain in depth. So over here, they give a key. If I was doing this if I was writing this on a physical like on a paper or something, I wouldn't be using U, I'd be using VI and VF instead of V, but basically the same thing. So yeah, you can use Clang or GCC or whatever, it's basically the same thing. And this is how you run it. Okay, so this is my GitHub. I have the releases in here, but oh yeah, I also have a .exe. That's good to know. Okay, now I'm gonna explain the how my program works basically. So what it does is it first asks like when you're running the program, if you see over here, you have to run it with use flags. There's two use flags for this, a --w and a --s. So the --w specifies which variable is missing from the equation, and --s is which one you want to solve for. Now I'll explain why this is the case, why you can't just enter the variables you want. And the thing is that there's five kinematics equations, right? And each of them has a variable missing. Over here in equation 1, there is no delta x variable. Over here in equation 2, there's no vf. Here there's no t. You get the point. Each equation has a variable missing, because you just can't have all 6 variables in one equation like that. The relationships just don't work that way. So that's why there's 5 kinematics equations for 5 variables. Each one has one missing variable. So that's how you get the --w part, the without, which variable you don't care about in your equation. Now the --s, that's basically allowing you to solve for that. So over here, for instance, this specific format, the computer can't really do algebra, at least not that I know of. So what I did is I had the base equation down here, and then I just sort of solved for each of the variables in this, and I have these as separate cases, but I'm going to talk about the logic of the program later on. But basically I'm just rearranging the equation so that it solves for each of these variables independently. I have it for all of the big 5, all of the variables. Some of these were a bit more complicated. I remember, this one, for instance, in equation number 2, solving for time, it has a plus minus over here, and those are trickier. For those, my program just outputs 2 values. It's as simple as that. You can pick and choose whichever one you want to use. Same for equation 5 for the time one. Okay, so now that you all understand how I got the equations which I'm using in my program, I'm gonna actually show you the program right now. So over here I'm just including the basic C libraries. I'm doing function prototypes here because I kind of just wanted to have these on the top, but you know, I want to keep my main at the top rather than the functions for these. It's just better for readability. In my main function, so this arg.c and argc and argv, that's basically the arguments you're running this with. You know, for instance, if you're running this right now, I would do /kinematics, or this completion, fish completion. Anyhow, so it's /kinematics-calculator.out, and then I have one variable that's missing and one variable that I'm solving for, right? So over here I'm missing A, which stands for acceleration, and I, which stands for initial velocity. So that's how we'd run it, right? So over here, these are like flags, parameters I'm running this program with, and for that you need to have this int argc argv thing, and there's a string comparison thing. So it's just evaluating evaluating that you have 5 arguments in this, including obviously the kinematics-calculator.out thing, because otherwise it won't work. And it's checking that the third one is --s. Sorry, not including kinematics. I made a mistake, but anyhow, now the second one, that's the variable that will be missed, and the fourth one is the solving one. But I don't think I do much with the solving variable in the main function. That's mostly in the other functions which I defined. Obviously, if you don't have if the missing variable and the solving variable is the same, I mean, that doesn't make any sense, right? You can't solve for something you don't have in the equation, so it's gonna return an error, this message. I have some other error messages, if you don't run it properly, it's gonna give these errors. Now I have a switch case thing. My friend was telling me that it's more optimized. I'm not sure about that, but I don't know, it looks clean, so I'm fine with it. Plus I'm just using characters, so it can work with switch cases and stuff, if statements. So it's just evaluating what the missing variable is, and based on that it's using one of those variables, those functions which I define later on. And obviously if it's not any of these, then that's an error, right? You didn't run it properly, so it's gonna print this error message. And at the end, once you're done with everything, it's just gonna say thank you for using whatever. Okay, yeah, I'm gonna move on. Okay, so this is the function for the first of the big 5 equations. It uses the solve one as an input. That's the only input it needs, because it's gonna input all the variables that you actually need separately later on. Switch, solve, oh yeah, so it's this just depends on what variable you're solving for, because depending on the variable you're solving for, you're gonna have to use a different equation, right? Because if you're solving for vi, then you're gonna use this, but if you're solving for t, you have to use this one, right? So it's like that. So for case you see I have get underscore input. That's another function I made later on, because it was kind of tedious to write printf and then scanf all the time, so I just made another function for this. Anyhow, I think it's 150 characters up, and It's way more up. Yeah. Okay, so that's what get underscore input is. Over here I have some I only have the 4 variables that are actually in the equation defined always, and it defines the variable using what value is returned from the get underscore input function. Over here I just have the string that I'm going to type in there. It's fairly straightforward. And then this line is the actual equation, and over here printf, that's just printing what the result is, you know, and it just does that for all of the variables in all of the equations. There isn't much more to say about this. I obviously have some error messages here and there. For A, for instance, in this one, yeah, when you're inputting for time, whenever you're inputting for time, but especially in this one, I say time cannot be 0 because you cannot divide by 0. Because when you're solving for A in this equation, over here, if you make time equals to 0, then you're basically dividing VF minus VI by 0, and that's undefined. And rather than printing out inf, which C does when you return something undefined, rather than doing that, I'd rather have it just tell to the user that time cannot be 0. So it just prints this out before it has an error. Elapsed time cannot be negative. This is more so just the thing I implemented because time can't be negative. But I didn't really do that properly. I think you can still put a negative time for some equations. It just depends. Yeah. So that's kind of just how most of my functions work. In the second one, there's an interesting part because when you're solving for time, if I remember, yeah, it has two answers, right? 2 solutions because of the plus minus. So what it does is it basically just has time and time underscore 2. So I'm defining 5 variables for big idea 2 and big idea 5 at the beginning because they have 2 time solutions, and I just wrote those separately, the equation separately, and then it just types both of them. Generally the positive solution is correct, but I'm just giving you both of them because I mean, why wouldn't you have both of them? You might as well just see both of them and pick and choose whichever one you want to use. For big idea 3, I think I have well, I want to look at big idea. Oh yeah, the reason there's 2 for these is because VF and VI are squared. So if you're solving for this, you're obviously going to get a square root and plus minus, right? So if you're solving for VF, for instance, then you're going to have to square over here, right? You're going to have to square root this whole side. So whenever you do that, there's a plus minus. So yeah, that's why I have 2 VI and VF variables. Apart from that, it's basically the same. I think you'll get the gist of how this kinematics-calculator works by now. At the end, it just prints it, and it doesn't return anything. It doesn't need to return anything. So these are all void functions because it doesn't return anything because it just prints the final output at the end. Okay, now I'm gonna show you a demonstration of how this works. So this is the get underscore input part, right? Right now I think I don't actually remember which big idea equation this is. We can actually find out, right? Oh, it's the 4th one because there's no acceleration, right? So if I run this, I can actually close this right now because we don't need it anymore. So it's without A, and I'm solving for I. So right now it's using this equation. But yeah, so it asks me what displacement is, from the get underscore input function. And I can say displacement, I don't know, like 4.5, time is 3 seconds, and final velocity might as well be like 6.7, I don't know. And it gives you the initial velocity to be minus 3.7 meters per second. I limited it to have 4 decimal points because I thought 6 was a bit much, but 4 is still relatively useful in AP Physics 1 classes. So it's useful to have 4 decimal points. It says thank you for using my kinematics-calculator, and that's it. That's how this works. I guess I can show you how to compile it, but I didn't make any changes. So if you were compiling, yeah, this thing, right? So it's you just write clang main.c or gcc main.c. It's basically the same thing for this. -o for output, and then kinematics-calculator.exe or .out. You can change the file name to whatever you want, honestly. Like, it really doesn't matter. -lm. I would prefer if you have it as kinematics-calculator as the output, because in all of the error messages it assumes that you have the name of the program as this. So yeah, -lm, that's so that it includes math.h, because if I do not include that by default, then it's not gonna compile, because I use math.h for all the power and square root functions in this. So yeah, you need to include a -lm so that it links the math.h header file. And now when I run this, it's the same thing because I didn't make any changes. But yeah, that's how you compile my program, and that's how you run it. Thank you all for watching this video. It's really fun to work on this. Yeah, that's it for today. See ya.